Hi everyone, thank you for watching my video. My name is Nur Adlin Fadhlina and I am a student of Unika Almimed. Now I am in semester 3 taking Bachelor in Naval Architecture and Shipbuilding. So today I will be presenting about the special design and maintenance for electrical equipment used in hazardous areas, relation to oil, gas and chemical tankers, and various explosion protected method used in same relation. So let's get started. What is hazardous areas? Hazardous areas are sites where fire or explosion hazard can occur in electrical and safety engineering. Sources such as hazard include combustible or flammable gases, vapors, dust, fibers, and flying debris, which are combustible or flammable. So the overview from the topics are: a light switch may cause a small, harmless spark when switches on or off. If a flammable atmosphere is present, the arc might start an explosion. Minimize the amount of electrical equipment installed in hazardous location. This can be done by keeping the equipment out of the area or by making the area less hazardous. And the last one is intrinsic protection design system that use minimum energy to work, inadequate to cause ignition. Designs for explosion-proofing devices involving ignition risk. For the hazardous zone classification, all vessels, in particular oil tankers, have areas or spaces which may contain flammable or explosive gas air mixtures. And in defining the hazards, hazardous zones are classed into zones which indicate the probability of explosive gas air mixtures being present. These two are the fire tetrahedron and dust explosion pentagon figures. So let me explain to you how this happened. Okay, when oxidizer mixed with fuel and ignition source such as thermal or electric, an explosion may be occur. Same goes with the explosion pentagon. When oxygen mixed with confinement and ignition and fuel and dispersion, an explosion may be occur also. For classification of hazardous materials following the American system, class 1 consists of flammable gases or vapors and divided into 4 groups, which is group A, B, C and D. Group A is acetylenes, group B hydrogen and hydrogen mixture, group C ethylene, ethers and some aldehydes, group D is alkanes. Class 2 combustible dust and divided into 2 groups, which is group E and F. Group E consists of metallic dust, which has resistivity of less than 100 kilo-ohm per centimeter. Group F is also a group G, consists of non-conductive dust and has resistivity larger than 100 kilo-ohm per centimeter. Class 3 have fibers or flying debris. Hazardous area on board ship consists of 7 zones actually, but I will be show you the 5 zones only. For the zone 0 is the flammable mixture is not continuously present or present for long periods. Zone 1 is the flammable mixture is not continuously present but will be present during normal operation. Zone 2 is the flammable mixture will not normally be present, but if it is, it will be present for a short period only. For the fourth one is the symbol of the safe closing door without holding back arrangement, and the last one is the audible and visual alarm in case of loss, pressure or failure of ventilation. This is the ship with the label of areas on it. As you can see, this is hazardous area. This one is 3 meters from opening, this is 4 meters from opening, and at the center of the ship is cargo tanks, and this is pump room. At the back side of the ship is engine room and normally safe areas. This is potential source of ignition. Should there be a flammable gas, vapor or dust in atmosphere, the following are considered to be potential source of ignition: socket and plugs, open fuses, light switches, relays, push button contacts, torches, starters, circuit breakers, electric belts, components like capacitors, inductors and resistors. Electrical equipment in hazardous areas of liquefied gas carriers. Carrying and handling liquefied gas cargo on board poses significant potential hazard, including risk of injury or death, threats to environment, and each person working on a gas carrier and terminal ashore needs to understand the risks involved, obtain the necessary training, and take all the needed precautions. Certified safe electrical equipment. The type of equipment recognized as safe for dangerous areas fall into the categories described below. First is intrinsically safe equipment. This is equipment relies on low power circuits to limit the maximum energy available to less than that necessary to ignite a flammable mixture under normal and certain fault conditions. To use of intrinsically safe system is limited to instrument, control, and alarm system because of the very low energy levels to which they are restricted. So this is a SAAB tank radar. The figure shows the diagram of the circuit and also the schematic circuit diagram. It consists of workstation, I/O box, level unit, signal board, processor memory board, interface board, backup display, transmitter interface, power block, and also transmitter. This is a diagram of a typical intrinsically safe installation. At the left hand side is non-hazardous location. At the right side is the hazardous location. As we can see in the diagram, this part is the vapor-proof seal and this part is intrinsically safe circuit. At the center and the left side of the box is non-hazardous location equipment such as contactors, relays, motor control center, and etc. The barrier relay must be mounted here. At the hazardous location, at the same side of the box, is hazardous area equipment such as standard push buttons, limit switches, intrinsically safe pilot light, and etc. This equipment does not need to be explosion proof. So this is a SAAB tank radar. The figure shows the diagram of the circuit and also the schematic circuit diagram. It consists of workstation, I/O box, level unit, signal board, processor memory board, interface board, backup display, transmitter interface, power block, and also transmitter. So for the maintenance step is, first one is cleaning the parabolic antenna, second cleaning an IG pressure sensor, third replacing an inert gas pressure sensor, fourth cleaning the cone antenna transmitter, fifth replacing a board in I/O box, sixth replacing the LCI interface board, seventh replacing the LCM processor memory board, eighth mounting a transmitter interface, ninth removing the transmitter interface, 10th replacing the LIA or analog digital power board, 11th replacing LIZ Zener barrier board, and the last one is replacing a card in a workstation. There are three classes of explosion protection method. First one is primary explosion protection. Primary explosion protection aims at substituting something else for the flammable substances or the atmospheric oxygen, or reducing their quantities to the point where there is no danger of an explosive mixture forming. Replacing the atmospheric oxygen is not an option for areas where people work. For this reason, the measures available for such locations are limited to avoidance or restriction of flammable substances which are capable of forming an explosive atmosphere, and avoidance or restriction of release the flammable substances and therefore formation of explosive mixtures both inside and around fittings by limiting their concentration, using enclosure filled with an inert substance, natural or artificial ventilation, concentration monitoring by means of a gas detection system which will give an alarm or switch off the system. For the secondary explosion protection, if, despite primary explosion protection measure, it is possible for a hazardous, potentially explosive atmosphere to form to a degree that requires measures to protect employees against explosion hazards, the ignition of this hazardous, potentially explosive atmosphere must be effectively prevented. All possible sources of ignition are evaluated and the appropriate protective measure applied. Effective sources of ignition on equipment and installation can, for example, be prevented using this type of protection corresponding to the necessary level of protection. The classification of potentially explosive area into zones, the frequency and the duration of the occurrence of a hazardous explosive atmosphere, and the local environmental condition forms the basis for defining the level of protection for equipment. It is furthermore necessary to know the key explosion-related figures for the flammable materials, such as temperature classes, dust ignition, temperature, explosion subgroup, and etc., as well as the local ambient conditions. The explosion characteristic help the owner or managing operator to be specified the risk in the area precisely and help the operating equipment manufacturer to select a suitable solution for the operating equipment, and finally, they help the installation engineer to select and assign the suitable devices. Ultimately, this data is found in the device labeling. For the tertiary explosion protection method, if the primary and secondary explosion protection measures are not enough, additional protective measures must be taken. The purpose of this is to limit the impact of an explosion and to reduce it to a non-hazardous level. The most common measure to limit the hazardous effect of explosion are as follows. Explosion-resistant design. Containers, apparatus, pipelines are built to be pressure shock resistant in order to withstand an explosion inside. The second one is explosion relief. Bursting discs or explosion flaps are deployed, which open in a safe direction if an explosion occurs and make sure the plant is not subjected to strain over and above its explosion resistance. And the last one is explosion suppression and preventing propagation of the explosion.